Welcome to the lecture series on transmission line theory. We are dealing with Smith charts. This is problem number 2. So in this problem we are going to find out how load and input impedance can be found with the help of Smith chart. So the problem says a load of ZL is equals to 100 plus J50 ohm terminates a 50 ohm line. What are the load admittance and input admittance if the line is 0.15 lambda long? So now let us start the solution. So in the question, the load impedance ZL is given as 100 plus J50 ohm. So if you normalize this with respect to the characteristic impedance of the line, that is Z0, which is given as 50 ohm, this will be 100 divided by 50 plus J 50 divided by 50. So this becomes equals to 2 plus J1 ohm. Now the normalized load admittance, which is the inverse of the normalized load impedance, we can write 1 over 2 plus J1. Now if you simply rationalize this, you will get 2 minus J1, 2 minus J1. So this becomes equals to 2 minus J1 divided by 4 plus 1, which is equals to 2 over 5 minus J 1 over 5, which is equals to 0.4 minus J 0.2 Siemens or mho. So you have found out the value of the normalized load admittance YL. Now in order to find the normalized input admittance, you need to follow 4 simple steps. The step number 1 is locate ZL in the Smith chart, draw VSWR circle, extend the line joining center of Smith chart to the ZL point in the opposite direction, and step number 4 is find YIN, that is input admittance, by moving clockwise direction, that is towards the generator. Okay, now let's do it one by one. So step number 1 is locate ZL. So we have found out that the normalized load impedance ZL is 2 plus J1. That is the value of the resistance is 2 and the value of reactance XL is 1. So if you just draw the constant resistance circle, RL is equals to 2, which is this particular circle, and the reactance circle 1, XL is equals to 1, which is this particular curve, you will find that these two circles intersect at this particular point. This particular point is the location of the normalized load impedance ZL. Okay, now step number 1 is done. Step number 2 is draw constant VSWR circle. So using this particular point, you are going to draw the VSWR circle. So from the center of the Smith chart, if you take this radius and draw a circle, this will become your constant VSWR circle. So this is your constant VSWR circle. Okay, now step number 3 is extend the line joining the center of Smith chart to the ZL point in the opposite direction, which cuts VSWR circle at YL point. So in step number 2, we have drawn the VSWR circle using this as a radius, and we have drawn this circle. Okay, now in this step, we need to draw a line from the center of the Smith chart in the opposite direction, which will cut the VSWR circle at this particular point. So this point is your normalized load admittance YL. So this is your normalized load impedance YL, which is 0.4 minus J 0.2. You can find it by zooming in. You will find that the value of resistance is 0.4 and the value of reactance curve is 0.2. Since this is in the lower half of the Smith chart, therefore we are going to use minus J. Now in order to denormalize the load admittance, you have to divide it with the characteristic impedance Z0. Therefore you have found that the value of YL is 0.008 minus J 0.004 mho or Siemens. And step number 4, we have to find the YIN, the input admittance, by moving 0.15 lambda in the clockwise direction towards the generator. How can we do that? We can just extend this line all the way up here. It will cut the scale at some point. Now since we are moving towards the generator, this is wavelength towards the generator, so we are going to use this topmost scale and we are going to move in the clockwise direction as shown by this arrow. So if you see, this line cuts this scale at 0.464 lambda, and from this point we are going to move 0.15 lambda in the clockwise direction. So if you move 0.15 lambda in the clockwise direction, you will reach at this point. So from this point, if you simply draw a line which joins the center of the Smith chart, it will cut the VSWR circle at some point, and that point will give you the value of the normalized input admittance YIN, which is 0.61 plus j 0.65 ohms mho, which can be found out by zooming in. You will find that the reactance circle is cutting at 0.61 approximately, and the reactance circle is somewhere between 0.6 and 0.7, which is this particular curve. So we are taking 0.65 as the reactance value. So therefore the value of YIN becomes 0.61 plus j 0.65 Siemens. You can denormalize it by dividing it with the characteristic impedance Z0, and you will find that its value comes out to be 0.012 plus j 0.013 Siemens or mho. Right. So in this problem we have seen that by using a Smith chart, how you can find the load admittance and the input admittance if the length of the transmission line is known, when the value of the load impedance is given, which terminates a 50 ohm line. Okay, thank you very much.